Every day, millions of smart meters are collecting data. The voltage, current, energy consumption, load profiles of your homes and appliances, and transmitting it to the utilities at real time. But have you ever wondered how does this complex data exchange stay reliable, standardized, and secure across different brands of energy meters, countries, and the communication networks? Behind this silent yet powerful communication lies a standard global level protocol, DLMS slash COSEM protocol. And in today's video, we are going to simplify this standard. We are going to decode how it works and show you why it is critical for smart meter technology, advanced meter infrastructure technology, and secure energy systems. Let's begin with something very relatable. Think about your smartphone. It stores contacts, send messages, and connects over the Wi-Fi and secure your data. A smart energy meter works in a similar way. It stores critical data like voltage, energy, current of your appliances, of your homes, and sends that data to the utility companies like PCS using the GPRS, Wi-Fi, RF, or the Ethernet protocols. But here is the catch. These meters are built from different manufacturers like Genus Power, HPL, Secure, and used across diverse networks. So, how do they all speak a common language so that the same utility server can get that information? And that is where comes the DLMS slash COSEM protocol, a globally accepted communication standard across the metering technology. DLMS COSEM is a universal language for smart meters. Just like English helps people from different regions communicate with each other, DLMS slash COSEM protocol helps different brands of energy meters, smart energy meters, different utility systems talk in a standardized and secure way. DLMS stands for Device Language Message Specification. It defines how messages are exchanged between the meter, which is stated as a server, and the utility, which is a client. So it includes authentication, session management, command structures, communication flow between the meters to exchange the data. In short, how the whole conversation happens and starts. Then comes the COSEM, which stands for the Companion Specification for Energy Metering. It defines what data exactly resides inside the meter, how it is organized, how which data packet structure it will be kept into it. And together, both DLMS and COSEM defines what to say, how to say it, how to secure it, and how to send any data of the energy meter across the meters and the utility services. Now, let's talk about the DLMS slash COSEM protocol in a very realistic and a layman terms, starting with the DLMS commands. Okay, so now think of DLMS is like a messaging protocol between a utility, which is a client, and a smart energy meter, which is going to be a server. And DLMS defines multiple command types, each with a specific function. Let's get into them. First is association commands. These commands are used to initiate or terminate the session between a meter and a utility. Commands like of AARQ, which is association response. Client, that is utility, initiate this session with this command. Then comes the AARE, which is an association response. The meter responds to the session request. Same way, there is an RLRQ, which is the release response. That is in this client, that is the utility, send the session to the meter to end the session. And then RLRE, this release response, meter confirms and end the session. So, and then comes the second commands, which are the access commands. These commands are used to interact with the energy meter data. Commands like get command. This command helps the utility to read the data from the smart energy meter. For example, active energy, reactive energy, voltage, current, or any other data. Then comes the set command. This command writes data to the energy meter for configuration of some settings or the updates. For example, update the clock by the utility side. Then comes the action command. This command triggers an operation in meters by the utility. For example, disconnect the supply or connect the supply again. Then comes the third batch of command types, which is the block transfer command. These commands use the large, they can transfer or receive the large amounts of data. For example, get with block reads the large logs of the meter by the utility. Same with set with block can write the large chunks into the meter by the utility. There are other groups of commands too, which we are not dwelling right now too much into detail, but these group of commands create a robust conversation tool and a model between the wide range of smart energy meters of different brands and the common utility servers or the gateways for communicating the smart energy meter data in a bidirectional. So if DLMS is a language, COSEM is a dictionary or a library that holds this energy meter data. Think of it like meter is a digital library, and each piece of data in this meter, like voltage, energy, time, is a book inside that digital library. To access a specific book or a data in the world of DLMS/COSEM terminologies, we need three items. First is OBIS code, tells where the book or data is. Second is interface class, tells what kind of book or data we need from that library. And third is the attribute, tells what page or the section to be read. Okay, now let's break it down these three in step by step. First is OBIS code. This is a 6-digit address that identifies a data point. It looks like A.B.C.E.F. and each field has a purpose. A stands for the medium, that is type of system. B stands for channel, that is which input channel or the phase need to be read. C is the measurement, which measurement, voltage, current, active energy, which measurement we want to see. Third is the measurement mode, whether the measurement mode is whether the value is instantaneous or the total or the average. Then comes the E, which is the tariff index, time of use of the tariff, and F stands for the historical index, that whether we want to read or write the current or the last month data. Example, let's say 1.0.1.8.0.255 means that active energy input, cumulative total, all tariffs and current reading. Next thing that we need is an interface class. This tells us how to interpret the OBIS object which we have just now got into. In this, there are three type of classes. Class 1 is data, text values like of meter serial ID. Class 3, which is register, numeric values like of energy or voltage. Class 5, which is a demand register, peak demand values of a voltage, energy, or the power. Class 7, which is a profile generating, time-based logs comes into that thing. And class 8, which is the clock, real-time clock inside the meter for logging. So if the OBIS code points to the total active energy and the interface class points to the 3, we know that it's a register with a numeric value in watt hours or in WH or the kWh that need to be interpreted. Then comes the third part, attribute. This points to the exact information that we need to see or write. Attribute 1 is the logical name, the OBIS code. Attribute 2 is the actual value. And attribute 3 is the unit and the scale factor of the readings. So when we send the get command of the DLMS for OBIS 1.0.1.8.0 interface class 3 and attribute 2, the meter will respond with something like total active energy equals to 12,000 WH. Okay, putting it all together, OBIS code, what you defines what you want. Interface class defines what type of data we want. And attribute defines what exact part of the readings we want. At Get2Byte, we are decoding the complex standard protocols like of DLMS and COSEM protocol specifically for the integration of embedded security mechanisms to the smart grid and the metering technology, so as to integrate the features like of secure boot, secure authentication using digital signatures and certificates, AES GSM-based secure communications between the utilities and the smart energy meters. Anybody who wants to know more about Get2Byte and our offerings, they can check out our website www.get2byte.com to know more about us. For now, stay subscribed to us, as in the next video, we are going to delve into the differentiation between the IEC 62056 versus the IEC 62351, that is the communication and the security standard for the metering technology. So for all the power and energy and industrial automation viewers and the enthusiasts, next video is going to be very crucial for you from the perspective of your products into this industry. Still then, stay happy and be skilled and senior, not just graduated one.